All right, let's get this party started. Hello, everybody. Hopefully you're well. Let's actually get the show on the road. Okay, so watching some of the comments here. Wolfram Alpha and Symbol Lab giving you different answers. I don't know. that doesn't sound kosher. I think you're typing the wrong thing into one of them. Also, I don't know. I mean, there are a few situations in which you might have an answer appearing different, but they're actually both correct. And these are things like if you're talking about equations of lines or planes. So for example, you should know that for the equation of a line, you can pick any point on the line to form the equation. So if one program decides to use this point versus that point, the equation might look different, but you'll realize that for different values of the parameters, you can recover all the same points. So, and we'll probably talk about that in a little bit as well. In terms of, yeah, grading exam 1 is going horribly because still not everything is fully organized yet. Like I have to be going in and organizing stuff. Anyway, in terms of the final, so we were talking about that a little bit earlier. So I called up Park today, asked him how the final was going. So he has finished written it, but at the moment, I couldn't get to ask him a lot of details about it because he was ripping his hair out trying to figure out how to get Blackboard to, how to get it to work in Blackboard. Yeah, Blackboard it's always a nightmare for me too. So I didn't want to probe him too much. But as far as what he said was it's about 25 problems long. So you have 2 hours and 15 minutes, and there are going to be 25 problems, which means that works out roughly to 5.4 minutes per problem, which is fine. Now, of course, it might sound like a lot, but if you take one of my tests and you actually break it down into parts, it's actually around the same length, believe it or not. So if you take like test 2, like without the bonus problems, there are 22 individual things you'd have to do for the mock test 2, if you actually count all the parts and all the different things that you had to actually do. That's like almost a full length final right there, comparatively speaking. So you guys can get that done in 1 hour and 40 minutes, which I believe you should be able to get that done in 1 hour and 40 minutes. The final time-wise shouldn't be that bad. Now, as for the types of problems, it seems like it's all multiple choice, and it seems like, yeah, so I don't think he can put any short answers in there. So it'll be roughly 25 problems to do over the course of 2 hours and 15 minutes. And as someone was asking also earlier, other than the fact that we're using Blackboards, I would say the protocol is otherwise the same, which means I do want, after the final ended, you to send me your work. Because I think, especially with a multiple choice, because with a multiple choice, it's easy to like make one little tweak and then you just get the problem completely incorrect just because of that one little tweak. So it's nice if I could have something to kind of see why you chose the thing that you chose, and maybe I could give you partial credit off of that. So other than that, it's just that instead of Top Hat, the final is going to be on Blackboard. Test 2 is still on Top Hat though. That's already set up and it's already assigned. So yeah, the final is going to grade you instantly. But if there is a shot at extra credit, so let's say your grade is unreasonably low. So I noticed that, hey, this student got a B on test 1 and test 2, and then his final is like a D. Then I would want to be able to look closer at that. You know what I mean? So it's not just a matter of, oh, the final's already graded for me, I'm not going to take the easy way out. Just going to want to make sure. Yeah, the final is still 65%. So a lot of other things are more compressed. I believe I had the grade breakdown somewhere. Where did I put it? Where did I put it? Yeah, so things are shifted around. Let me try to find that grade breakdown. So I think this is how things are gonna go. All right, let me actually share my screen. Boom. So there's the OneNote document, and let me turn off video and make sure the chat is open. And yeah, so it seems like that's the new grading policy. So the grading policy that I gave you guys is obsolete, and that's going to be the grading policy. And that's the final exam date here, just as another reminder. But that's what we got to do. Now, on the surface, I think overall, unless you like get tricked, the final will probably be easier than it would have otherwise been. But it still has that possibility of someone knowing what they're doing and still getting things wrong, which is why I'd want to have your long form answers as well. So that if there's ever a reason for me to doubt the grade on the final, I'll have something that would advocate on your behalf. So Blackboard is going to be grading things instantly, but I still want to know. Yes, you need 8. So remember what I told you as the policy. You need to score at least 85% overall on the homework, and then I'll give you 100% for your homework grade. So to get that full percentage, that full 10% towards your overall grade, you need to get at least 85% of your homework correct. You're at 84.7. All right, you need to get those 0.3 extra points. Try to finish up the last few and be perfect. Yeah, so so let's say, again, I'm going to make sure to try to be as fair as possible to people. So let's say the final grades you and the final gives you like a 45. But then I realized, oh, this is a student who got like 85 on test 1 and then 88 on test 2. The 35 or the 45 would be out of character. And then I would then go with that student, go and look at their work and see, well, why did they get that 45? You know? And if it's something like, oh, it's just like a trick question or something, then I might give you more credit for that one. So reopen the sample test on Blackboard. I don't know. Is it closed for you guys already? It closed at 6 p.m. Now, hopefully, you actually went through the sample test on Top Hat. As a secondary measure, I did post a PDF version of the test on the class website. So if you go to the class website, you should, under test 2 review, there is a copy of the mock test posted there. Okay, so again, the mock test, it's a mock test. There will be about 25 items for you to go through. You cannot move forwards or backwards through the questions. So you will pretty much go through question 1, question 2, question 3, question 4, and etc. So you can't move back. So make sure you're right the first time. And make sure you're not spending more than like 5 minutes per problem. Okay. Other than that, let's actually jump into no, you have to give me your work at the end of the final. You'll still have a 15-minute window. So the final would be from 3:30 p.m. to 5:45 p.m. By 6 p.m., everyone needs to upload their work. Because I mean, if I'm looking at the grades like a week later and then I ask you to show me your work at that point, I mean, it's a week later. Like anything could have happened in that week. You know what I mean? Top hat, probably. That would be nice. And I mean, a couple days before the final, I'll give you guys specific instructions on how I want you to complete it. So we're going to do it on Blackboard, but I do expect you guys to write down your answers. Try to do the problems in order. If you plain old guess, write down, just have a reason why you guessed what you guessed. I mean, that would be fine with me. If you're like, I eliminated these as the possibilities and then I randomly guessed between the other two possibilities. I mean, that I would actually give you some credit for that. Like if you have a good reason for knowing why the answers were not the answers, then yeah. So literally, I need to know what went through your head at any point is the whole thing. All right. Anyway, let's get into the meat and potatoes of today. So today, this entire week, in fact, we are going to be doing reviews. And I assume today, now I might be wrong, but I assume that what you guys would probably want to do today is go through the mock test. Am I right or am I wrong? Or are we all cool on the mock test? First of all, did everyone do the mock test? Is the first thing. Now, mock test 2. At least, did some people do it? Do we have people who did it? Okay, so now this is probably, I don't know, I might have like 5 people left over after making this request, but I would actually say, like, if you haven't done the mock test, then you actually should not be on this lecture watching me go through the mock test. It's not going to be very efficient or useful, and it's going to be very easy for you to misinterpret how much you actually know, right? Because at the end of the day, math is deductive, it's logical. So if you see me go through the steps, in hindsight, it's going to make complete sense to you. You're gonna be like, oh yeah, obviously that's what we should have done. But for you to have known that before someone showed you the answer is a whole other story. And so if you stay on this lecture, you watch me go through the mock test, you can come away confident. Yeah, you know what? I could have gotten a 90 on that. When in reality, you would have gotten like a 65. And there's not going to be any way for you to actually know. The only way you're going to actually know is if you actually did it by yourself in the first place. Like it's going to be very easy for your brain to trick you, which happens all the time, which is this is a part of the reason why students often feel like their math teachers are trying to make them fail, because their measurement of their own understanding doesn't match up with the grade that they got. And a part of that is because they go to class and they pay attention, and every time the professor writes something on the board, it makes complete sense and they feel like they understand. But the thing is, that's because they're watching someone knowing what they're doing, writing down the answers on the board. It's going to make sense in hindsight, right? But if you were there at the board at the time, could you have done what your professor did on the board? Most of the times the answer is no, right? Because you don't have the experience, you haven't done enough practice or anything. So watching me do the problems versus doing them on your own, these are two very different things. And so I would say, if you haven't done the mock test, you should log off and go do the mock test. That is a better preparation for you. And then you just watch this video after I upload it to YouTube at some other point. Or maybe probably better than that even is just to join tomorrow's lecture, in which case I think the Tuesday, Thursday class might want me to go through the mock test as well. But yeah. So. Well, I'll post this lecture. Well, this lecture will be posted on YouTube tonight at some point, and then your test will be on Wednesday, so you should have enough time. But I would definitely recommend you going and doing the mock test by yourself before. And if anything, you can probably join tomorrow's class or watch this video later. All right. As for the rest of you, if you did it, the mock test, we can run through it. It might give us cause for more discussion that we could also bring in tomorrow. But if you haven't done the mock test, I would recommend logging off and spending your class time doing the mock test, as opposed to watching me go through the mock test. All right. Okay, that being said, I suppose, all right, take care. Yeah. Good night, good night, good night. All right, and I guess for those who are sticking around, we can begin. So what I would say is that, I don't know, I may or may not ask for input, but if I do ask for input, just jump in with what you tried or what you did. You can jump in audibly and just say, I did this, and just we can move on. But yeah, let's actually go through question 1. Okay, let the games begin. So this is question 1. What did you guys try? How do you convert from rectangular coordinates to polar coordinates? Did anyone actually do this? Right, so you can use the fact that you know that, so for 1a, use the fact that you know that r squared is equal to x squared plus y squared. So this means that your r is equal to the square root of radical 3 squared plus the y is -1. That's going to be 2. Now, technically, you can do a plus or -2 here, but I'll just set it up so that we take the +2. And then for theta, you can write that as the tan inverse of y over x. And so that would give us a theta would be tan inverse of y over x. So now you realize, where is the tangent equal to minus 1 over radical 3? Well, that is, of course, at pi over 6 is where you would get positive 1 over radical 3 for the tangent. So to get the negative, you get negative pi over 6. And so I would say r comma theta is equal to 2 comma minus pi over 6. And you can double check. You realize that this is actually going to be in Q4. And so that's correct, because radical 3 comma minus 1 is in quadrant 4. So no reason to doubt those answers as long as you know your trig well enough to know where your tangent would give you that. You could also use, in this case, you could also use x is equal to r cosine theta, and then you plug in, say, radical 3 for the x, and you plug in, say, radical 3 for the x. The r you just found is 2, and so now you have cosine theta. You'll get cosine theta equals 2 over radical 3. Or you could use the y is equal to r sine theta. And so you'd have minus 1 equals 2 sine theta, and you can solve for theta that way. Well, I would say no, to not leave it as tangent inverse. First of all, let's say this is a multiple choice problem, then I would definitely put what the tan inverse of 1 over radical 3 is, as opposed to doing yes, the mock test is on the class webpage. Hold on. Let's see here. Let me share. Where is my browser? Share. So Jhevon. So if you're in GH, you click on that. Then if you scroll down, see test 2 review, all the way to the bottom there, click on that. Although the test should still be on Top Hat, from what I remember. I think the test on Top Hat is open until tomorrow at 6 p.m. So I'd rather you do it on Top Hat if that's the case. This is for people who are not in my class who want to do the mock test, because I'm actually substituting for another class and they might want to do it. Okay, that's strange. I can double check on Top Hat right now, but I'm pretty sure that the Top Hat should still be live. Okay, let's. Hold on, I'm setting the Okay, so it's definitely set for the Tuesday, Thursday class to be closed tomorrow. If I look at the Monday, Wednesday class, the mock test is definitely still open for. Yeah, the mock test is open, so you should be seeing it. So I'm seeing no issues on this end. Okay, yes, so everything is good. Everything is good, Kevin. I just wanted to double check on Top Hat that everything's fine. It seems everything is fine, so try again. All right, so for B, let's actually go through that. So we have convert that to rectangular coordinates. And here you would just use the other set of equations. So your x is equal to r cosine theta. So this is -2 cosine 11 pi over 6. Now 11 pi over 6 is in the fourth quadrant. And so all students take calculus, you'd realize that the cosine is positive there. So it's going to be the positive value of cosine pi over 6. We know that cosine pi over 6 is radical 3 over 2. So this is minus radical 3. And then our y is equal to r sine theta. Again, this is the fourth quadrant. All students take calculus. The cosine is positive, but the sine is negative. So this will give you -1/2. And so that's +1. And so your x comma y would be 1 comma minus radical 3 comma 1. And if we look at C, describe this region. Well, notice that if you look in the XY, we have a circle of radius 1. That's where the x squared plus y squared equals 1. Then we have a circle of radius 4. That's where the x squared plus y squared equals 16. Clearly, I want what's in inside the circle of radius 4, outside of the circle of radius 1. Now, at the same time, I want my x to be less than or equal to 0, which means I want to be on the right side, on the left side of this thing. And at the same time, I want my y to be greater than or equal to 0, which means I want to be above the x-axis. And so you kind of fill in the guy that would be doing both of those at the same time. So that's the part we care about there. And at that point, it shouldn't be too hard to give a bound for the r and a bound for the theta. We cover the entire second quadrant so that theta goes from pi over 2 to pi. And our R values go from 1 up to 4, which is the radius, the distance from the origin. And so that's how I would describe that with inequalities. And I assume we're going to be fine with that. Now, hopefully if you did that, that's how it looks. And then now we can go to problem 2. Now let's actually start speeding things up a little bit here because we had a few hiccups and I don't want to go too much over time today. So I'm looking at this one, problem 2. So remember, our dy dx is just going to be our dy dt divided by dx dt. So dy dt is going to be 4t cubed over dx dt, which is 9t squared minus 5. And that's your answer there. Look at B, equation of the tangent line at C of C when t equals 1. So this means, of course, I need a point. And that means our x is going to be 3t cubed minus 5t evaluated at when t equals 1. This is 3 minus 5, which is minus 2. And then my y is going to be t to the 4th plus 1 evaluated when t equals 1. That's going to be, well, 2. And so this means that minus 2 comma 2 is our point. Then we're going to want to find the slope. Now the slope is just going to be dy dx evaluated at when t equals minus 1. And that, I just go to the answer in part A, plug in t equals 1, and I would get 4 divided by 4. So that's 1. So I would take m equals 1. And then I would just say, well, it's y minus y1 equals m x minus x1. That's the equation of my tangent line right there. And here it says set up, but do not compute an integral to find the arc length. So remember, that would be the formula a to b integral of the square root of x prime of t squared plus y prime of t squared dt. And so this will be 0 to 1, the square root of x prime 9t squared minus 5 plus y prime, which was 4t cubed dt. And that's going to be the formula there. And that's problem 2. Okay. I know it wasn't bad, Kevin. I think so too. Now the question is, when you were going through the first time, did it seem worse than when I just went through these 2 problems? You struggled to get through the 2 problems that we just did? Problem 1 and problem 2? Yeah, but now when I did it, it didn't seem so bad, right? Right, this is what I'm saying. This is why I'm trying to tell you guys that to watch someone do something, even if you go to class and you pay attention, it's different than actually doing it on your own. And that's where there's always this kind of misjudge, like people don't know how to judge themselves and they go into a test overconfident. Rarely a student will go into a test underconfident, but that happens too. But that's a whole other issue. But a lot of times students will feel that like they're a lot better. And then when they get back the grade and it's like, I don't know what happened, I think I do better than this. Like, this is what's happening, okay? So you have to remember, hindsight is 20/20. So if you see me go through something, it's going to look a lot easier and feel a lot easier than it actually is. It's very important that you go through the experience of trying it on your own first. And you'll realize it's two different experiences. So a lot of times I'll do something like, oh, that was it? Yeah. Let's do problem 3. So it was just to do a bunch of sketches. So we look at the first one. A. Now remember, from this, you should notice that this guy is a cylinder, right? You know that because only 2 variables. Then you want to think, well, how do I graph a cylinder? Well, first you graph it in the plane of the guys that show up. So you are going to have, you know, this, that's X, and that's Z. You know, this is just like a parabola. And so now you can actually move on to the 3D graph. So you recognize that it's a cylinder, and then you go about, well, how do I graph cylinders? Well, you first graph the 2D curve, which here is in the XZ plane, and then you extend that curve along the axis of the missing variable. So that's going to be your curve right there. Right? So it's a cylinder, a parabolic cylinder, in fact. If you look at part B, now that has all 3 variables present, so you know it's not a cylinder. In fact, that is going to be a no, not necessarily. I mean, if you can just get to this graph right away, I wouldn't care. Like you don't have to show this technically. I just wanted to show how you would build it. But now, if we're looking at this one, then yeah, you'd realize that this is a quadric surface. So if you wanted to build it from scratch, you could draw traces, but you could also jump straight to the 3D version. And you realize that on the Z, if you look in the ZX, you will see an upside down parabola. On the Y, you would again see an upside down parabola. And then, yeah, you kind of just combine those guys together. So you get that's a paraboloid, upside down, extending down. And of course, this goes on forever, but you get the idea. If you go to the third one, but again, here, yes, you could have drawn the traces. So we could have said something like, draw it in the XZ plane. and draw it in the YZ plane. You could also draw it in the XY plane. And you'd realize over here, XZ plane, it would look like an upside down parabola along the X and the Z. In the YZ plane, it would again look like an upside down parabola in the Y and the Z. And then in the XY plane, you'd realize that you would get like a circle of radius 1, which is going to be the guy here. Should have been the other way. And so you can go through the traces or you can draw it from scratch. But either way, you could put the traces on the 3D picture itself. You just imagine what wall that you're drawing it on at the same time. And then you can go from there. If you look at, say, this one, again, you realize that that is a quadric surface. So you can graph the traces. So if you look in, say, the ZY plane, that is a parabola going up like that. This is Y versus Z. And if you look in, say, the XZ plane, that is a parabola going down like that. If you look in, say, the XY plane, then you have this going on. But then you put them, and another useful thing here is to graph in say Z equals 1. You'd realize this would look like that. It's a hyperbola. If you graph that with X versus Y. And so you kind of put these guys all together. And you realize that, well, there's a curve that goes like this way, another one over here that goes that way. Then you're going to have in the ZY plane curve that connects. That connects this to that. And you're going to realize that in the XZ plane, you're just going to have a curve that comes over here and goes like that. And then you kind of put those guys all together. And that's going to be your picture for that one. Then we look at D. Now D you should recognize as a plane, again, right by after looking at it. So those guys are fine, hopefully. You should just be able to draw them right off the bat. X, Y, Z. So you set Y and Z equals 0, you get X equals 6. Set X and Z equals 0, you get Y equals 2. And then you set X and Y equals 0, you would get Z equals 3. And you connect these with straight lines. That's your plane right there. Would it have been the same with y squared equals x squared equals y squared? Yeah, because if you get x squared equals y squared, this, right? If you set x squared equal y squared, you can square root both sides, you'll get x equals plus or minus y. So this is x equals y, this is x equals minus y. So yeah. But this is called a degenerative conic. These lines actually are inside this curved dome part, but you're not seeing them. No, it's not a hyperbola. Hyperbola would be like y squared minus x squared equals 1 is a hyperbola. A hyperbola is not a straight line. This here would be like y squared minus x squared equals 1. That's where the hyperbola comes from. It's not y squared minus x squared equals 0. Right, the general form of a hyperbola would have like a 1. Well, if you hadn't chosen that, you just have this green curve and this red curve to go by. And if you can realize that that is a hyperbolic paraboloid, then that's fine with me. I don't know. This just gave me extra information. Remember, the idea of traces is just draw as many traces as you can to get something useful that you know how to sketch it from. Now, the reason why I chose z equals 1 is because it would be very hard. I won't understand, especially if you don't have a lot of experience. Seeing these two parabolas and then those straight lines would probably confuse you. Like you won't know how to get to the picture from that. But because I know what the equation of a hyperbola looks like so well, because Jhevon asked us to memorize those things, I realize that if I have a difference of squares equaling 1, that's a hyperbola. And that's why I chose z equals 1. Because here I see a difference of squares. Right, and that means something to me in another context. So when you're choosing traces, it's not random really. You are choosing things such that you get curves that you understand, you know how to graph them on their own, and then you put them together to get this new beast in 3 dimensions. So me choosing z equals 1, it's a choice that I made because I know what the general form of a hyperbola looks like. And I know it's a quadric surface. And we know that quadric surfaces come from the conic sections. Like the quadric surfaces, the traces that are convenient for us to sketch are from the conic sections. So that's why that choice was made. All right. And that's problem 3. Go to problem 4. All right, now this one should be interesting. This one was probably a challenge. I think, at least conceptually speaking, not that these are hard, but these were probably a challenge for most students, you know, just going by experience. I think problem 4, and maybe even problem 5 a little bit, is going to be a challenge of how to get those. Now, everything that we did before that, technically speaking, if you have the table 6 memorized, should be easy for you sketching these. And of course, if you have all the formulas memorized, that's also not a bad problem. None of these problems, if you know these formulas, you are should be okay in actually getting through these. When you get to problem 4 though, you can know all the formulas and still be stuck on these, right? So it's just a matter of you need to know how to use the ideas and the formulas that you are given and put them together in a creative way to actually get through these problems. And creative is in quotations here, because if you do enough of these problems, you're going to realize that there are not many different situations someone can put you in and ask you to dig yourself out. So if you actually practice most of the problems in the textbook, there comes a point where you can even memorize the strategies to every possible plane or line problem that I could ask on a test. That being said, knowing about all the things like cross products and dot products, equations of lines, equations of planes, you need to know how to use the tools that you're given to figure out something that you want to find. So let's actually work through this one. Let's work through problem 4. So problem 4. So find the equation of the following. The plane that passes through that point that's perpendicular to the planes with this and that. Now here's something that you'd want to realize. So A, to be perpendicular to two planes, to this, perpendicular to the planes with those equations. What you would want here is you would want the normal, means you have to be perpendicular to both their normal vectors. Right? So basically, it's like you have these two planes hanging out. Right? Or whatever. And you want a plane that's perpendicular to both of those at the same time. Right? So that means his normal vector is actually going to be orthogonal to the normal vector here and the normal vector there. Because you'd have these guys being pointed out like that. And these guys are all at 90 degrees. So essentially, you want, for one, and another way you can look at this is for one plane, or you can think of it this way, for one plane to be orthogonal to another, its normal vector needs to be parallel to one of the other plane. Okay, and so you want that to happen to two planes at the same time. And so how would you actually accomplish that? Well, essentially you're going to do a cross product. So now the normal vector for one of these planes, you remember how to find the normal. That would be to take the coefficients of x, y, and z. So that's the normal of the first plane, and the normal of the second plane is that. So the normal that you want is going to be the cross product of these two. So that would be 3 minus 0, comma, 6 plus 2, and then you take the negative of that, and then you take 0 minus 1. So that's your normal. And we know the point is 151. So this means your plane is going to be, well, 3 times x minus 1 minus 8 times y minus 5 and minus 1 times z minus 1 equals 0. Where the numbers inside come from the point. So this is where you get the 1 from. This is where you get the 5 from. And this is where you get the 1 from. And if you look at this, the 3, the minus 8, the minus 1, that's these guys here. And so that's going to be the equation of the plane you want. Yeah, to do the dot product equals 0, you would kind of get in trouble doing that because you'd have to do two sets of dot products. You'd have to dot product with this normal vector and at the same time dot product with that normal vector, and then figure out a vector that does the job of both the dot products. Now, on one hand, if you remember the lecture on the cross product, you would realize that one way to actually derive the formula for the cross product was to do exactly that. So if you approach the problem that way, what you would actually be doing is re-deriving the formula for the cross product from like first principles, which it's not that it's the wrong way to do it, but you're reinventing the wheel. Like the cross product is already a thing. So you can actually shortcut that by just jumping right to the cross product. So conceptually, that's not a wrong way to think about it in terms of dot products, but it's not very efficient for this problem because you need two sets of dot products on three-dimensional vectors. You'll get a system of equations with two equations and three unknowns, which means you're going to have to pick some guesses to get it to work out in your favor. So yeah, it's not worth doing it that way. Here, just do the cross products. Now, if I look at part B, the line of intersection of the planes, it's actually a similar concept that you can apply here in terms of the trick is a cross product. So it's like here now we have two planes. And they meet in a line, right? So here's a plane. I don't like how that looks. So here's one plane, and there's another plane slicing through this plane. Right? And we want to find the line of intersection, this line that passes through both planes. Now, here's what you want to notice about the line of intersection. It's actually parallel to both planes. Which means it has to be orthogonal to both normal vectors. It's actually very similar to the other problem in the sense that the direction that you wanted had to be perpendicular to both normal vector directions. And that tells you cross product is how this problem is going to be dealt with. Now, of course, you need a point on the line. So you need to make sure a point on the line is in both planes. So you have to put these two facts together. So you know, for one, the direction in which you care about is going to be a direction that is orthogonal to both normal vectors, and the point on the line that you care about has to be a point that is in both planes at the same time. Now, on one hand, that's going to involve some guessing and checking, because you have to find a triple x comma y comma z such that it works in this equation, x plus y plus z equals 1, and at the same time, it works in the second equation, x minus 2y plus 3z equals 1 as well. Now, remember, the point is not unique. So let's focus on the point first. For definiteness, I don't know if there should be an E here. For definiteness, I would just pick where I want one of the points to happen. Choose the point in the, say, XY plane. So this means I'm going to force Z to be equal to 0, and then I need to solve for the other two. Well, that would mean that my x plus y equals 1 and my x minus 2y equals 1. Well, that would mean that your x equals 1 and your y equals 0, right? And you Either you can do process of elimination to figure that out, but I think at this point it's kind of obvious, which means at this point, the point is going to be 1, 0, 0. So that's the point on this line that you want. Now, when you're looking for the direction of the line, we know that comes from the cross product of the normal vectors. So our direction vector is going to be the normal 1 cross product with the normal 2. And so those were, again, the coefficients of x, y, and z gives us the normal. So that's going to be 1, 1, 1 for the first guy. And then it's going to be 1 minus 2, 3 for the next guy. So that's going to be 3 plus 2, comma, 3 minus 1, which is 2, but you take a negative of that. And then you blot this out, minus 2, minus 1, you take minus 3. So that's your direction vector. And then you kind of put those together. So this means that your line is going to be x, comma, y, comma, z. And you remember the equation of a line, it's the point 1, 0, 0 plus t times the direction vector, 5 minus 2 minus 3. That's the vector equation of the line, and the problem didn't specify which form it wanted, so that's fine. I want you to notice, for example, and this might, so note, another answer could be, could look something like 6 minus 2 minus 3 plus t times 5 minus 2 minus 3, right? That's another way you can get the line to look. Now, these are both the same line, even though they would look different. And in fact, I could make this even look different than that. This vector I could say is 10, comma, minus 4, comma, minus 6. Now, this would be also an answer. So there are times when you can have answers that might look different on the surface, but you'd realize that you can scale these guys and you can pick any point you want. It's also through that 6 minus 2 minus 3 is also going to be on these coordinates, because if I take 6 minus 2 minus 3, I get 1. If I take 6 minus 2 times a minus 2 plus 3 times a minus 3, I would also get 1 again. So there are many points that I could have picked and many direction vectors. And you would notice that, for example, I know that 1, 0, 0 is on this line because I can plug in t equals 0 and get that point. But I can also notice that if I were to plug in t equals minus 5 into this, I would get that point here as well. I would get 1, 0, 0. Minus 1/5. Minus, not minus 5. It would be minus, I need to subtract 5. Yeah, minus 5 would actually get me that guy. So, yeah. So once you can recover all the same points, you would realize that it's actually the same line. So for this, I can get, undo. For this, I can get 1, 0, 0 by setting t equals 0. And this one can get 1, 0, 0 by just setting another t. And I think minus, because let me see, what would we have to pick for t here? Because I would need 10t to equal to minus 5. So t would equal to minus 1/2. And they would both give me the same coordinates. And we can do this for all coordinates. So on the surface of it, your answer might look different, but really these two answers are the same. And hopefully if you have issues with, say, Symbolab and Wolfram Alpha seemingly contradicting each other, a lot of times it might be a situation like this, where they're both giving you the right answer. It's just that they randomly chose a different point. So it's like Symbolab might decide, oh, I'm going to pick the point to be living in the XY plane. And then Wolfram Alpha might say, I'm going to choose it to live in the XZ plane. So the coordinates going to look different. And it might even scale the normal vector differently. Like Wolfram Alpha might decide, you know what, I'm going to choose a normal vector I'm going to choose a unit vector to describe the normal. And so that plus another point is going to look like the answer is different. But the answer is actually, they're both equivalent. Meaning you can get the same points just by changing the parameter value. Your parameter here can range between -infinity and infinity. So yeah. So that is how you'd find the equation of a line of intersection. At least that's the vector form. Now the last one, C. So this for C. Remember, the angle between two planes is the angle between their normal vectors. Because the normal vector describes the direction of a plane. And so you just want to find the angle between their normal vectors. And so you actually have an equation for that. So this means if I take the normal of one dot product with the normal of the other one, this is going to be the magnitude of the first normal times the magnitude of the second normal cosine theta. And we want this theta. I was literally going to write out the word theta. We want this theta. So this means that my theta is going to be cosine inverse of, well, it's going to be n1 dot n2 over the magnitude of n1, magnitude of n2. And so that is going to be cosine inverse of 1, 1, 1 dot product. What's the other vector? 1 minus 2, 3 divided by the magnitude. So this is going to look like the cosine inverse of 1 minus 2 plus 3. So that's just 2. Over radical 3, radical, it's 1 plus 4 plus 9, 14. And that would be the answer there. The general equation for the cross product? I'm not sure what you mean. Like this is the formula for the cross product. You just take the determinant of ijk, you line up one vector in one, line up the other vector in the other. I don't know if it's an equation, it's a formula. It's a mnemonic for you to figure out how the vector happens. So yeah, and that's problem 4. If we look at I think we already did that here. Problem 4, I already copied it down here. Yes. So now we're moving on to problem 5. Find the point on the plane, boom, that is closest to the point 3, 1, 7. The n1, n2 cosine theta, that has nothing to do with a cross product. That has to do with the angle between two vectors. This is an equation that talks about the angle between two vectors. We covered it in the dot product section, not the cross product section. Like the dot product of two vectors always obeys this equation. Okay. So here, what is the idea here? So here we have our point. It's our 3, 1, 7. And we might have our plane over here doing its thing. We want to find the shortest distance. Well, what is the shortest distance? It's going to be the perpendicular distance, right? So I want this perpendicular distance is the shortest distance. So if I can find a perpendicular line that goes from the plane to that thing, we want this point. So here's what we can do. Find the equation of the red line. Then find where this line intersects the plane. Now, the equation of the red line shouldn't be a problem. So for the line, we know that a point on the line is going to be the point of consideration, 3, 1, 7. We also know that the direction of the line is just going to be the actual normal vector direction. I want a direction that's orthogonal to the plane. So that's just going to be the normal vector, 1, 2, -1. So this means that our line looks like x is equal to 3 plus t, y is equal to 1 plus 2t, and our z is equal to 7 minus t. Right, so it's 1, 2, -1. Right. So now what you do is just plug into the plane. So the plane is actually x plus 2y minus z equals 16. So I'm just going to plug that in. X, 3 plus t, plus 2 times the y, 1 plus 2t, minus the z, 7 minus t. That should give us 16. So this is 3 plus t plus 2 plus 4t minus 7 plus t equals 16. This means that on this side I have 6t. It's t plus 4t plus t. And then on that side I have 16 minus 3 minus 2 plus 7. So that's 11 plus 7, that's 18. So t is going to be 18 over 6, which is 3. And so the point that we care about is going to be the points here. And just you just evaluate those at t equals 3. So this means your x would be 6, your y would be 7, and your z would be 4. So the point is going to be 6, 7, 4. And that's that one. Let's see here. What's the other one? Ooh, limits. Yeah! Everyone's favorite thing. Okay. Start with the first one. All right, let's see. 4 and 5 scare you? Well, that's just 4 and 5 are definitely the ones where you need the most creativity, I should say, at this point. But again, if you go through a lot of the homework problems, you go through a lot of the problems in the textbook, you'd realize, like when it comes to asking you to find the equation of a plane, what are the things they can ask you? You know, there are not many situations. They can ask you, okay, a plane perpendicular to 2 other planes. We covered that in this class. A plane that contains 3 points, sure. A plane that contains a line and a point, sure. A plane that contains this that is orthogonal to some other direction, sure. Like you're gonna realize that there are only a few situations they could ask you for. So one way is to just discover all the situations, which by just reading through your textbook, you'll see all of them eventually. And another one is just really understanding what a cross product does, what a dot product does, and how things work in 3-dimensional space. And then you can kind of figure things out. So, which is what my comments here are hopefully putting across. Like this is what goes through my mind when it comes to actually figuring out like what I actually want to do, right? So I make the comments here before I start the problem as to why am I doing what I'm doing. It's because these are the ideas that come to mind when I realize, oh, to find a line, I need a point and a direction. Given this information, how would I find the point and the direction? And then I kind of use what I know about cross products and dot products to develop that. Anyway, the limits hopefully were easier. Let's do the first one. Exists or not exists? What do you think about this one? Exists or not exists? Yeah, but no, like tell me what you think the answer is. Like, what did you prove? Did you actually successfully prove something one way or the other? So you think it does not exist. And how did you prove that? So once you think it does not exist, that means you tried 2 different paths and you see they didn't give you the same thing. What were the paths that you tried? X equals 0. So if we go along x equals 0, we would get our limit would be the limit of, well, y to the 4th over y to the 4th, which is 1. And another path? You said y equals minus x? Y equals x? So let's see. Along y equals x, your limit would look like, well, let's change everyone to x's. X to the 4th minus x to the 4th plus x to the 4th over x to the 4th plus x to the 4th. And that would give you a half. So yeah, limit does not exist. Got two different answers by going along two different paths. Let's look at the second one. Exists or not? D and E. What paths did you choose? I mean, for this, it looks like the same paths would work, right? So you can go x equals 0 or y equals 0. Let's do y equals 0, but x equals 0 would give you the same thing. Along y equals 0, your limit would look like, well, the limit of 0 over 3x squared. So it's going to be 0. And along y equals x, your limit would look like the limit of x squared over 4x squared. So that would give you a quarter. So yeah, you got two different answers, two different paths. Limit does not exist. And now we can look at the third one. Exist or not? Exist? Oh, so we have a difference of opinion here. So who is right? So if we let's see. So maybe let's actually try. So when you're not sure, of course, you just try to show it does not exist. So along x equals 0. So your L will be the limit of, well, 0 over y squared. So you get 0. And you found a path that got you something different. Okay, so you also did along y equals 0, the other obvious path. If you go along y equals 0, you get the limit equals the limit of x squared over x squared, which is 1. So yeah, limit does not exist. So those two paths give you different things. This one, exist or not exist? You did which one the long way? The last problem? Oh, I'm not sure what long way you were talking about, but anyway, for D, the limit as x comma y approaches 0 comma 0, if x cubed over x squared plus y squared, exist or not exist? Right, this one actually exists. You would realize that if you can try a bunch of points, you can try along x equals 0, y equals 0, y equals x. you'd all realize that the limit gives you 0, which is suspicious. So here you would try to put in the guy x cubed over x squared plus y squared minus 0 in absolute values. Well, that's just x cubed over x squared plus y squared. That is less than or equal to x cubed over x squared. That is equal to the absolute value of x. And notice that this guy approaches 0 as xy approaches 0, 0. So taking g of xy, this shows the limit is equal to 0. Or you had another option here. You could switch to polar. You would get the limit as r approaches 0 of x cubed was on top. What was on top? X cubed was on top. So you'd have r cubed cosine cubed theta over r squared. This is just the limit as r approaches 0 of r cosine cubed theta. That's 0. So that limit actually exists. Two good tries is enough for you to be suspicious that it doesn't exist. So if you try those obvious paths and the paths that allow you to actually simplify the situation, normally at this level in a Calc 2 or Calc 3 class, those two choices are going to discover a problem whenever one exists. So at that point, you kind of get suspicious and you try to do like a squeeze theorem or polar coordinates or something similar. Anyway, what about this one? E, exists or not exists? D and E, what are the paths? I guess one obvious path would work. So along, say, x equals 0, you get the limit is equal to 0 over y squared, limit of that. So that's 0. What is another path that you picked? Y equals x. Let's see what we get here. Along y equals x. So the limit would be equal to the limit of, let's plug in all x's for y. So this would give us x squared cosine 2x over 2x squared. So this would be the limit of 1/2 cosine 2x. Now as x is approaching 0, this gives you 1/2 cosine 0, but cosine 0 is 1, so this gives you 1/2. That's different. Limit does not exist. And that's done with problem 6. So the problem 7. You loathe the Leibniz notation? Like, you don't have to do it if you don't want to. You do have to recognize when it's being used and what it means, but yeah. Anyway, so this says find the partial derivative with respect to x, then with respect to y, then with respect to z. There are some situations in which the Leibniz notation is definitely the more convenient notation to use. I will say in the prime note, like definitely if we're talking about the Leibniz notation versus the prime notation in single variable calculus, there are definitely disadvantages to the prime notation in certain situations. Like for example, in differential equations. However, with the subscript notation, I think the subscript notation actually overcomes those disadvantages. So I'm pretty sure if you only ever use the subscript notation, I can't think of a situation where that would actually lead to confusion. But don't quote me on that. But definitely the prime notation has disadvantages in some contexts. But at the end of the day, you do need to understand whenever the Leibniz notation is being used, you need to know how to interpret it for sure. Because not everyone is partial to, pardon the pun, is partial to the subscript notation. Some people actually like the Leibniz notation. Anyway, that being said, you need to know what this means. And this is an exponential. So notice the order does not matter here. Order of partials does not matter. Since this guy is continuous everywhere. So Clairaut's theorem takes effect. And so you can actually do the partials in any order. Now, there's no reason to actually change the order here. I don't particularly see an advantage in doing the y or the z before the other one. So yeah, I don't really see an advantage. Let's just go straight in. Partial with respect to x, it's the derivative of the power times the original function. Derivative of the power times the original function x, y, z squared. And partial with respect to y of that, now you're going to need the product rule. Now, was there a way to avoid the product rule? So we'd have to use the product rule here. Maybe with respect to z is actually easier, but let's see. Now that I think about it. Now, I wouldn't waste time actually thinking about this. It's easy enough to just jump in and not care, but partial with respect to z, yeah, no, it's not really gonna save you any trouble. So I would just do it directly. So partial with respect to x, multiplied by the derivative of the power times the original function. Partial with respect to y, we're going to need now the product rule because there's a y out here and there's a y in the power. So you differentiate the y, leave everyone else, plus you leave the yz squared, and then differentiate the exponential. So this is z squared e to the x y z squared plus x y z to the fourth e to the x y z squared. And you could factor out a common e to the x y z squared if you wanted to. And so this is x then y. And so now if we take x, y, then z, product rule here, or I think I actually prefer to actually factor out the common. This would be z squared plus x, y, z to the fourth. And do the derivative of the first factor. Leave the exponential plus leave the first factor and differentiate the exponential with respect to z. So this is 2xyz e to the xyz squared. And ultimately, that's the guy you want. What do you mean what just happened? I just took the derivative. So in the first case, I take the derivative with respect to x. And again, here we're using the fact that the derivative with respect to x of e to anything is the derivative of the thing with respect to x times the original function. So we're just using the derivative rules. And I keep doing that. Now in the second part, once I do that, now this, if I want to take the derivative of this with respect to y, I would need the product rule because there's a function of y here and there's a function of y there. So I did the product rule. Then I grouped it at the end. And then for the partial with respect to z of that, I have to do the product rule again because there's a function of z here and there's a function of z here. So I differentiate this, leave this alone, then differentiate this, leave the other one alone. Yeah, so that's what happened there. And that's problem 7. So that ends the actual test. And I think we made pretty good time there. I think we definitely beat an hour and a half there, even with me explaining and looking at chats and stuff. So hopefully that will be fine. Now let's look at the bonus. So let's see here. What would the bonus? Now this is A cross B, so it's just again, within this test, you'd have to have taken cross products like a few times. So 1 minus 1, 1, 2, 2, 1. So that's minus 1, minus 2. 1 minus 2, which gives you minus 1, then you take the negative of that, then you cross out the last one. 2 plus 2 is 4. That would be your answer. B, find the area of the parallelogram formed by A and B. That is just actually the magnitude of the cross product. So it's going to be the square root of 9 plus 1 plus 16. So that's going to be the square root of 26. C, find the smallest angle between A and B. And this is, again, using that formula we had. So we know that A dot B is equal to the magnitude of A, magnitude of B, cosine theta. So this means that theta is going to be cosine inverse of A dot B over magnitude of A, magnitude of B. And if we take A dot B, that is 2 minus 2 plus 1. And if I take the magnitude of A, that's radical 3. Magnitude of B is going to be radical 9. So that would be your angle there. So this was like for the people who, you know how to do a cross product and all that good stuff, but for some reason you didn't realize how to put this all together in problem 4. So at least the bonus gives you a chance to show, I really do know how to do these things, Jhevon. I couldn't figure out how to actually use it. Right, so that's what this bonus problem was about. So in case you didn't know when a cross product actually would have come up in the test, you can at least show me that you do know how to take a cross product. And you know the fact that the magnitude of the cross product is the easier way to find the area of the parallelogram. Now, if you go to bonus problem, sketch the surface. So here we realize that, oh, this is Z equals sine X. And so that's really, I put X here and Z here. Looks like the sine function. So that's a cylinder. So now you just actually extend along the Y. So if you go into 3 space, kind of have this thing going along here. And now you pretty much just extend that guy along the y-axis. So this is here. And then this will always curl up back and then go on. So it looks something like that, but this part of here, obviously, it's not gonna. Just looked way off. So it looked like that, like this folded sheet just going on forever in both directions. So that's that surface, just figuring out that it's a cylinder, and you should have most of that figured out. Oh, wait, hold on. Yeah, so busy about wrapping up. We didn't do all the derivatives. Okay, let's. Move that over there. We're here. Okay, yeah, so this one, the 6th partial derivative. So this says you take the partial with respect to z 3 times, then you take the partial with respect to y 2 times, then you take the partial with respect to x 1 time. Yeah, so let's jump into it. Partial of u with respect to z, where's just the power rule? So c x to the a, y to the b, z to the c minus 1. Partial of u with respect to z again, c minus 1, c minus 1, c, okay, c minus 2. Partial with respect to z again, c minus 1, c minus 2. X to the a, y to the b, z to the c minus 3. Then you do the partial z partial y. So now this becomes bc, c minus 1, c minus 2, x to the a, y to the b minus 1, z to the c minus 3. U, z, y is going to be b times b minus 1, c times c minus 1, c minus 2. And we had to take the partial with respect to y twice. Now we take a partial with respect to x. So this is u, z, y, x. And now you just take the partial with respect to x. So it's a, b minus 1, c minus 1, c minus 2. X to the a minus 1, y to the b minus 2, z to the c minus 3. For this one, you'd realize here you need implicit differentiation. Because your z is actually mixed up. So you would go through, and essentially you want to find the partial with respect to y of this whole equation. And so in the first case, you need the product rule, differentiate the y, leave the z, plus you leave the y, differentiate the z. Plus the x is a constant, so that just becomes that. And on this side, z is the inside function, so 2z partial y. And now you just want to solve for this guy. So that is going to be y minus 2z times the partial of z, partial of y, equals, now I'd move them to the other side. So this is minus z minus x over y. Plus. Right. Or you could use the formula. You could use that partial z partial y is the same as minus fy over fz, where your f of x, y, z is going to be, well, you bring everyone to one side. You don't have to know that way though. That's a formula that you're going to learn in the next class. So yeah. Yeah. So let's see, where did we put that other guy? Okay, here. Now we got the bonuses after that. And this was the third bonus that we had to do. Bonus problem 1, bonus problem 2, bonus problem 3. Yeah, a lot of letters for that last one, the partial derivative. Okay, so find and sketch the domain of that. So just remember how domains work. We need, let's put this in the other one. We need the 9 minus x squared minus 9y squared to be greater than 0, which means we need x squared plus 9y squared to be less than 9. Or a nicer way of writing that is we need this to be true. Now, why is that a nicer way of writing it? This is inside an ellipse. Because Jhevon forced me to memorize what an ellipse looks like. So the domain of this function, did we call it f? Yes. The domain of f is going to be the set of all x, y such that x squared over 9 plus y squared should be less than 1. So that's a part of the answer here. And what would that look like? Well, it's going to be everywhere inside an ellipse. Centered at the origin, but you move 3 units in the x direction and 1 unit in the y direction. Now, technically, we want the smaller eraser. You don't want to include the boundary here. But you do want everything inside that boundary. So that would be what the graph of the domain looks like. So find and sketch the domain. So that, yeah, that's the domain. Need everything to work inside this ellipse. Last bonus problem. Way up here, way up here. Sketch the contour map. So remember, a contour map is just sketching the level curves, right? So this is just sketching the level curves. And so that just means you want to sketch things that look like y e to the x equals k, where k constant. What does it mean to sketch that? Well, I can just solve for y. This just means I'm sketching a bunch of y equals k e to the minus x for different k's. And so realize that if k equals 1, that's just the... So I have y equals 1 e to the minus x if k equals 1. But of course, I can go higher, k equals 2. And I have k equals 3, and so on and so forth. K equals 0 would be literally along here. So k equals 0 is going to give me the x-axis. K equals negative would give me the guys that are bouncing over here. So that's what these level curves would look like. The y-intercept is the value of k. But that's what your level curves would look like. And that's basically it. So that is it for this test. And again, I'll post a PDF of this, but hopefully you actually tried the full test on your own, because trust me, doing this by yourself and watching me do it are two very, very different things. So it's good that it refreshed your whole memory. Going through this test actually is, it's almost like going through the second half of the semester. Like we pretty much touched on everything we covered after series. Going over test one would cover the first half of the semester, and it should do a lot in sort of jogging your memory. So hopefully that was helpful. Of course, it's more helpful if you tried it yourself and then you saw what I did, because then you'll kind of know what you understand, and then you'll know what to pay attention to with what I said, and that's going to help you fill in your gaps for the actual test. One thing I would say about the test is, I believe, now I actually wrote it last week, so I don't fully remember. It's very similar to this, but I do remember that the actual test, and I believe this was in maybe a subsection of problem 4 or something like this, does cover, so in problem 4, or was it problem 5? There was a where I asked you about a distance, the point with the closest distance to something. Yeah, so problem 5. Distances in the form of, what are those guys called again? Projections. So for problem 5 is where I really test your notion of distances. So the whole point of this problem is to test distances. Do you have the concept of what it means to be the shortest distance and do of that sort? So you should know about vector and scalar projections, because we actually use those to derive distances. You should also have a concept of distance from a point to a line in general. Also know about distance from a point to a plane. And I believe this was covered in the cross product lecture, if I'm not mistaken. Let's see, is it here? Or was it with the equations of lines and planes thing? Yeah, distance between points, lines, planes. All right, so make sure you know how to do, for example, I would say no last example in equations of lines and planes lecture. Yeah. Other than that, you just have to, I hit on the same topics in the test. It's going to be very similar to this. So if you know how to deal with this, you will be fine for the test. All right. Anyway, it's been forever. Let's actually just wrap up here. We'll stop there. As always, I will post the PDF and the video to this. And I'll say that. Stay safe And good luck, everyone. I will see you later in the week. So if you're in the GH section, your test is on Wednesday. It's going to be very similar to this. And if you're in the RS2 section, your test is on Thursday. It's going to be similar to this. And yeah, so the final, don't know fully what that is, but I do know it's going to have around 25 problems in that time. It's going to be multiple choice. And so, yeah. Good night, everyone. Stay safe. And that's a wrap. Ciao.